Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode from ID 2338. Count the number of ideal subarrays. In this problem, we will be utilizing dynamic programming and combinatorics. We are going to first solve this problem with recursion with memorization in the standard way by analyzing our problem and subproblem, and then further optimizing it with the help of combinatorics. So this question is marked as hard, but don't worry about that. You will be able to understand it completely, and it is asked in Microsoft Infosys. Let's have a look at the problem statement. You are given two integers n and max value, which are used to describe an ideal array. So inputs is just two integers. A zero index integer array ARR of length n is considered ideal if it is following the below two condition. First condition is every value in this array is from 1 to max value. So utilizing this second input. And second condition is every array of I is divisible by array of I minus 1. I minus 1 means previous element. Every element in the array is divisible by the previous element. If these two conditions are satisfied, then array is considered ideal array. Return the number of distinct ideal arrays of length n. This array is also having length of n. Since the answer may be too large, return it modulo of 10 to the power 9 plus 7. We have to take the modulo with 10 to the power 9 plus 7. And what we have to return, in short, return the number of distinct ideal arrays. So how many ideal arrays we can form. So this is something given in the problem statement. I will just explain it again to you with this example. Given part is two integers. First integer and second integer. First integer is n. N is specifying the size of ideal array. Size of ideal array is n. And what is the max value? Any value in this array cannot exceed max value. It can go from 1 to max value. So this is the first condition I need to follow. And the second condition is that every element in this ideal array is divisible by the previous element. I plus 1 is divisible by I, or you can say I is divisible by divisible with I plus 1 is divisible by I, or you can say I is divisible by I plus 1, which is in the problem statement. Array of I divisible by array of I minus 1. Same thing is there. And divisible means taking modulo, using modulo operator, it is coming as 0. So these two conditions should be fulfilled by the ideal array, and ideal array is of length n. So in this way the ideal array is formed using these two variables, and what we have to form is return the total number of possible ideal array we can form using these two values, which are going to satisfy that ideal array is of size n and none of the value is exceeding max value. Here let's try to see how many ideal arrays we can form of size 2. If it is a size of 2, it means we have two spaces to place the value, and the values will be from 1 to max value, starting with 1 and going till max value as per the input example. So 1, 2, 3, 4, 5, these are the possible values that we can use to form the ideal array. And in the ideal array, I need to take care of this condition as well. Every element is divisible by the previous element. What about the first element? That can be anything. So let's try to fill the first position. In the first position, I can either take 1, 2, 3, 4, 5. I can take anything, right? 1, 2, 3, 4, 5. And if I just come to the second position, the element we are taking at the second position should be divisible by, let's say this is B and this is A. So B modulus A should be 0. And in this case, A is 1. We have to choose B. B can be anything because everything is divisible by 1. So B can be anything. So that's why I have taken every single element. And here I have chosen 1 again. Why? Because every element is divisible by itself, right? A is definitely divisible by A. So that's why we are going to pick the same element again. So with 1, I can pick anything. 1, 2, 3, 4, 5. In total, 1 is going to give me 5 possibilities. If the first item is 2, then the second item can be either 2 because 2 is divisible by 2, or 4. Apart from 2 and 4, none of the item is divisible by 2. So if we start with 2, we are going to get 2 ideal subarrays. And what about 3, 4 and 5? There is only one option. None of the item is divisible by these values 3, 4, 5 apart from the number itself. So 1, 1, 1. And what is our answer? Our answer is the sum of these ideal subarrays. And sum of these ideal subarrays are 5 plus 2 plus 3, which is 10. So 10 is going to be my answer. We have to return 10 for this example. So I hope the problem statement is now clear to you. Now we will try to see how we can generate all the ideal arrays. So these are the ideal arrays and we have to now generate it. If we take the same example where n value is 2, it means my ideal array is going to have size equal to 2 and the values it will be having from the range starting from 1 and going till max value. Max value is 5 here, so the range will be 1, 2, 3, 4, 5. And now I can just start picking the items. See, for the first position I can pick anything. I can pick any value because there is no previous value, and the condition that current element should be divisible by the previous element is not valid on the first element. So first element I can pick any item from this range. I can pick 1, 2, 3, 4, 5. So any item I can pick. If I am picking 1, I am left with 1 space. 3, and in this case 4, and in this case 5. Now at the second iteration, so this is like position 0 and this is position 1. In this position, what value I should choose? I can choose any value which is divisible by the previous one. Previously I have chosen 1, and now in this position I can either choose the same value because same value is divisible by the previous one, or I can pick multiple of the previous one. See, at this position either I can choose 1 or I can choose any multiple of 1. Any multiple means 1 into 1 is 1, 1 into 2 is 2, 1 into 3 is 3, 1 into 4 is 4, 1 into 5 is 5, 1 into 6 is 6, but 6 is out of the range, so just discard 6 and pick any one of the values, right? So any values I can pick after 1. And what about after 2? After 2 I can pick any value starting from 2, and that is a multiple of 2. So initially I have chosen 2. At this position I can either choose 2 or choose 4 or choose 8. 2 into 1, 2, 2 into 2 is equal to 4, 2 into 3, that is going to be 6, so we can pick 6 as well, and 2 into 4, that is 8, we can choose 8 as well, but 6 and 8 are out of this range. The range is till 5. So here the two basic possibilities are 2 and 4. So after 2 I have only 2 options. And what about after 3? After 3, one option is 3 itself, because 3 itself is divisible by 3. And what about 3? After 3, so 3 into 1 is 3, 3 into 2 is 6, so 6 I can also take, but 6 is out of the range, so I'm not going to take 6 and subsequent. So 3 is the only option. So after 3 I can take 3, and after 2 I can take 2, 4. After 1 I can take 1, 2, 3, 4, 5, and after 4 I also can take 4, and after 5 I can only take 5. So if I just try to cleanly write this recursion tree, after 1 I have 5 possibilities, 1, 2, 3, 4, 5. One possibility is I'm taking 1, 1. I'm taking 1, 2, 1, 3, 1, 4, 1, 5. After 2 we have 2 possibilities, 1, 2, 2, 2 and 2, 4. 3 we have only one possibility, 3, 3, 4, 4 and 5, 5. If I just try to count these ideal subarrays, 5, 5, 4, 4, 3, 3, 2, 4, 2, 2 and 1, 5, 1, 4, 1, 3, 1, 2, 1, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are 10 in numbers, and this 10 is going to be my answer. So here what I did is, firstly I initiated from 1 to max value these number of calls. So starting from 1, for I equal to, let's say that is 1, I is equal to 1, I less than equal to max value I plus plus. So this is going to be my starting position. My starting position, and what length I have captured so far. See, I need to fill this array, and this array is of length n, and initially I have chosen one item 1 2 3 4 5, so it means one length is already utilized. So I will just initialize length with 1. When the length is equal to 2, it means after this the length is 2. So at the length is equal to 2, just don't do anything, just count 1, that return 1. So after this returning 1, after this returning 1. So start is this and length is 1, and this is going to be my helper function. From the main function I can call this to initiate max length number of calls, max value number of calls. Starting from 1 till max value, I'm going to initiate this call, and this start is I. And this okay, now let's try to see what we can do in the helper function. In the helper function, it is taking a start position and it is taking length, and what it is going to return is how many ideal subarray we can form using this combination starting and length integer. Initially the length was 2 for ideal subarray. At the first position I have initiated 5 calls from 1 to 5, and I just moved further to fill the second position. For the second position, what value I can pick, and that is dependent on start. Any multiple of start I can take, any multiple of start which is less than max value I can take. But what if this length is equal to 2? In that case we just have to capture it. It means that one ideal subarray we are able to get. If length is equal to n, let's say n is globally declared somewhere. If length is equal to n, then directly return 1. So this is going to be my base case. My base case is this. And what about the processing? Processing is after this start, take any value starting with this start, and that is multiple of start. So let's say initially at the first position I have taken 2. What value I can take for the second position? That can be 2 into 1, 2 into 2, and 2 into 3, anything. So I can write a loop for this. The value I can take for this position is, let's say value, and this value is going to start with start, and this value should be less than equal to max value. That is a condition for our ideal array. And this value plus equal to start. What does plus equal to start mean? It means if I am starting with 2, I can pick 2, I can pick 4, I can pick 6, I can pick 8, I can pick anything. Any multiple of 2 I can pick. Now solution of, now the starting position is my value is the starting position, and what is the length? Length is incremented by 1, and whatever answer it is going to return, that is going to be captured in the answer variable. Answer variable initially is 0. In the end I can return answer. So I am able to capture all the ideal subarrays. So this is the code we can write. If I just write this code on the IDE and I show you how it is working, it will look like this. So this is the code that I have written for this recursion. Initially I am going to initiate the call for every possible value, and whenever I am picking any possible value, I am capturing the length. The length is 1 because I have chosen one value. And in my helper function, if the length is becoming equal to n, it means that one ideal array I have formed. So that is going to contribute 1 to my answer. And just keep moving further. Go to the subsequent call. Count plus equal to solution val, comma, length plus 1. Now this recursion is going to give me all the ideal arrays. If I just try to run over sample test cases, let's see if it is working. This is working fine on sample test cases, but still in this recursion there is some scope of improvement, and this solution call I can memorize over these two values, start and length. Now let's see how we can do it. Now as we saw that this helper function I'm going to call with these values, taking two parameters. First one is starting value, and the second value is value length, and the length value will go from 1 to n, and the starting value will go from 1 to max value, and this is going to return me the integer. And how we are going to come to this conclusion that these calls are going to be overlapped? Let's say I have taken 1 1, my n is equal to 3, and I have taken 1 1. At this position I can take 2, and in some other call I have taken 1, I have taken 2, and at this moment I can also take 2. So here at this position value is 2 and the length is also same. Value and length is also same. So these are two subcalls that is coming. It means whatever are the variable parameters, start and length, just memorize it. And the start value will go from 1 to max value, and the value of length will also be going from 1 to till length, both inclusively. So max value plus 1 size for the first dimension and plus 1 for the second dimension. So my DP array can be like this: max value plus 1 and length, not length, this is n plus 1. And after doing the memorization, see, before the memorization, what is the time complexity? Time complexity is definitely at every step we are taking a couple of values out of this range, and definitely that this value is more than 2. So it's way more than 2 to the power n. Whatever value we are picking, raised to power n steps. And after doing the memorization, it will be in a quadratic time, n square time maybe. So which is a significant improvement, and this is something recursion with memorization. Now I will show you how to implement the memorization into this recursion, and let's see if it is working fine or not. Now here in the code, what I have done is I have taken a 2D array, 2D integer array, so that I can head a condition check. If it is not equal to null, it means I have stored something, otherwise I have not stored something. So DP can be initialized with the value max value plus 1 and plus 1. This is my DP table, and my answer is the same. In the helper function, I am doing the processing here. So whenever we use DP, before doing the processing, we check in our tabulation, in our DP, that whether the answer is stored or not. So before processing, I will check whether this combination is already processed and captured or not. If it is not captured, do the processing, and after processing, just capture it. And why I have introduced this modulus and all, it's already given in the problem statement. Take a modulo 10 to the power 9 plus 7. So 10 to the power 9 plus 7 modulo I am taking, and taking it at every step whenever we are incrementing in the answer or count. So this is just a simple memorization with a 2D matrix, and let's see if it is working or not. It is working fine, and if I just try to submit it, it must give us TLE or memory limit exceeded. It is giving me TLE, time limit exceeded. Let's see how we can further optimize it and save some time out of it. We have applied dynamic programming, but still we are not getting correct answer, and we are getting TLE. Let's see where we are doing wrong here and where is the scope of improvement. I have taken an example where n value is equal to 4 and max value is equal to 4. Max value 4 means the values in the array can go from 1, 2, 3, 4. and the n equal to 4 means the ideal array is of size 4. If it is of size 4, what is the value I can place at the first position? At the first position, I can place any one of these values. I can either place 1, 2, 3, 4. 1, 2, 3, 4. And now what about the second position? I have placed 1. What about the second position? Second position, I can place anything, any multiple of 1. Any multiple of 1 is 1, 2, 3, 4. 2, 3, 4. 1, 2, 3, 4. And what about the third position? First two positions are 1. What about the third position? I can place anything. 1, 2, 3, 4. 1, 1, 1. And only one position is left. And at this one position, I can place anything. 1, 2, 3, 4. Because these 4 are the multiple of 1. Okay. Now the first position I have fixed with 2. And on the second position, what I can take is, I can take 2. And on the third position, I can also take 2. So what I'm saying is that we are taking same element again, and that is going to cause some duplication, and we are getting into the calls too many times. And if I just try to write it and show you by the example, see, our array is of size 4. The first possibility I will get from the left side of the recursion is 1, 1, 1, 1. And the next possibility I can get is 1, 1, 1, 2. 1, 1, 2, 2. 1, 2, 2, 2. See, you can see here that we are having so many duplication, and these duplication and getting into the calls again and again, it is going to cause TLE, or in some cases we might get or end up into the memorization, memory limit exceeded error. So we have to avoid this situation. This situation is something we need to take care of, and how we can do it. Instead of the same element, if instead of the same element I'm just discard taking the same element again and again, where is our code? Our code is something like this. In this code, value is equal to start. Value is starting with the first multiple. Like for every value of 2, the first multiple is, first item where the 2 is multiple is 2. The second item is 4. Third item is 6. Like this. So to avoid duplication, just skip the first item. Skip the same item. So instead of say same item, I can start with start into 2. If I do something like this, if I do it, I might end up having values. Having values in this case, I can have values like this. If I start with 1, start with 2, start with 3, start with 4. These are the possibilities I can start with. If I start with 1 and I go into inside the recursion, and the next item I can pick is double of 1. And the next item I can pick is double of 2, double of 4. Double of 4 is not allowed. So it means I can pick only these 3 values. And if I just start my recursion with 2, I can pick 4, and after 4 I don't have any possibility. After 3 I don't have any possibility. After 4 I don't have any possibility. So these are the only possibilities I can have for my 4-digit number. So either you use these 3 values and form a 4-digit value, either you use these 2 values and form 4-digit array, or you directly use 3, directly use 4. So this is something where I can think of, that avoiding the same case, avoiding the case where I'm getting the same element again. And these value, why I'm not going ahead of 4? Because the limit is max value. I cannot cross any value which is greater than max value. So this is the only possibility I got. And as per the constraints, did I capture the constraints? No. In the constraint, I saw that this value of max value and n, they are going till 10 to the power 4. And this 10 to the power 4 is something, if I write in terms of 2 is power, I have to take log with 2, and taking with log 2 for this value, it will be coming around 13 point something. Let's say it is coming around 14. In this case, the depth of this recursion tree will be 14. Otherwise, it is 14. Otherwise, if I just keep on taking the same element 1 1 1 1, it can go around 10 to the power 4. The depth can go around 10 to the power 4 in this case. If let's say the n is 10 to the power 4, I will keep on going inside the recursion. But instead here what I'm thinking is, instead of taking the element in that order, I'll just take how many unique items I can have in my ideal array. So in my ideal array I can have these many items, and this is something I have shown to you that how it is going to optimize it, because at max I can have 14 possibilities. So you can say 14 possibilities I'm going to have, or you can say recursion tree depth is going till 14. So it's a significant improvement. And let's say if, how we are going to get the answer. If I started with 1 and I got the possibility that 1 2 4 I can use, I have to form an ideal array of size 4, right? And the possibilities I got are 1 2 4. It means that 1 can be used multiple times, 2 can be used multiple times, 4 can be used multiple times, and we have to fill this array of size n. If they can be used multiple times, they will be used together because it is increasing order. I can't use 2 and then 1. I have to use 1. It means some portion of 1. Some portion of 1, some portion of 2, some portion is filled with 2, some portion is filled with 4. To be precise, what I'm going to do is, I can say that this array is definitely going to have 1, 2 and 4, because the possibility where I'm not having 1 is captured as a part of this case 2 4 3 4. So this case is where we are having 1 2 and 4 in our ideal array. If we are having 1, at least one time we are going to have it. Let's say at the left part of this bar I'm having 1, then I also have to accommodate 2. Let's say at this portion we are having 2, at this portion we are having 4. So let's say these values are all 1, all of these values are 2, all of these values are 4. So this is something I can take as a part of my ideal array. So this is 1 2 2 4, ideal array of size 4. So this is valid, yeah, completely valid. 1 1 2 4 is also valid. 1 1 1 2 4 4 is also valid. So these are the possibilities I also need to capture now. Here, if you just try to analyze, at one portion I'm having 1, at some middle portion I'm having 2, at some right portion I'm having 4. So I just need to cut this section of size n into 3 portion. For 3 portion I need to decide two positions. Like, let's say before these are the indices 0 1 2 3. Before 1 I'm going to make a cut, before 3 I'm going to make a cut, right? And total how many cuts I can make? Before 1 I can make, before 2 I can make, before 3 I can make. It means total 3 cuts I can make. Size was 4 and total cut is 3, which is equal to 4 minus 1, or I can say n minus 1 cuts I can make. And how many cuts I am actually making, that is dependent on the possibility, how many unique items I'm going to capture inside that recursion tree. So that is 1 2 4. So if I have to accommodate 3 items in my n size array with some duplication, for 3 items I require 2 cuts, 3 minus 1, right? Because 1 is the left portion, 7 is the middle portion, 1 is the right portion. So this is 1 2. 2 cuts are required for 3 items. It means total number of cuts were n minus 1. And I have to choose how many cuts? 2 cuts, which is k minus 1. And let's say the size of this possibility, size of unique elements are k in number, and size of this array is already n. And this n size array is, before 0 I can't make a cut. Why? Because at least one time this item should be there, otherwise it is not from this case. So I hope you got the idea that this is 4 size array 1 2 3 4. 4 size array means indices are 0 1 2 3. This is 4 size array. I can either make cut here or here or here. if I just make 3 cuts, I'm getting 4 portion. So 4 items can be accommodated here. But in this case, we wanted to put 1, 2 and 4 on this array. So we required only 2 cuts. Let's say I just remove this cut, and now this array is divided into 3 portion. Total, how many cuts are there? This. 3 cuts I can make, which is equal to 4 minus 1. So n minus 1 cuts are available there. And from those n minus 1 cuts, if duplicates are 3 in number, so 3 minus 1 cuts, or let's say it is k, the k minus 1 cut. So n minus 1, c, k minus 1, n, c, k. So n is 3 here, 1, 2, 3. And k minus 1 is 2 here. So 3c2. 3c2 possibilities I can make, which is equal to 3 factorial divided by 2 factorial into 3 minus 2 factorial. And this is the formula of NCR. If I just try to solve it, 3 factorial is equal to 3 into 2 factorial divided by 2 factorial into 1 factorial. It is 3. And what are the cases I used here is 1, 2, 2, 4, 1, 1, 2, 4, 1, 2, 4, 4. 3 cases. 3 cases I can generate where I'm going to use 3 different values and the array size is 4. So that value is ultimately is equal to n minus 1, c, k minus 1, and k minus 1 is the unique items I can pick along that recursion tree. So if I just start filling these values from, let's say, 4, next time I can pick is 8. Next unique value I can pick it 8, and that is something 16. So these unique values I am picking, and based on those unique values, these are k in number, and the array that I need to form is of size n. So this is the formula for that: nc k, n minus 1 c k minus 1. And for NCR, you already know the formula: n factorial r factorial divided by n minus r factorial. So this formula you need to know. And here how I'm going to do it. See, if you just go and have a look on the recursion code, the value is starting with start. Instead of starting with start, if I just started with start into 2, double of start. If I started with double of start, and every time I'm just starting with the double of start, I will be having how many items are there at every position. So this is how we can avoid taking up duplicate elements. See, I will just show you the code for the recursion tree, but before that, let's say you are able to figure out k. N is already given to us, and we have to figure out k. What is k? For n, what are the possible values? Possible values are 1, 2, 3, 4, and the max value. And in this recursion tree, recursion branches, how many unique values we can have it in every single subsequent call? That is k. And for every value of k, what I need to figure out is n minus 1 c k minus 1. So now you have to decide how you're going to calculate NCR efficiently. This is also a tricky part in this problem, and this part is called Combinatorics. So we are going to utilize DP with Combinatorics. DP plus Combinatorics is utilized to save TLE from this problem. That's why this problem is hard, labeled as hard. And also you need to know how to efficiently calculate NCK. For that, you must be aware of some kind of triangle. Let me show you how. To calculate the value of NCR efficiently, I'm going to tell you a very important concept. See, you must be aware of this triangle. Let me draw it for you. So this is 1, and this left portion is 1, right portion is 1, and this left portion is 1, this right portion is 1, this portion is going to be something else. Now we are having 4 items, and in this case left and right extreme value is always 1. So here if I just try to fill it, this portion is going to be sum of these two values, that is 2, and this portion is going to be sum of 1 plus 2, which is 3, 2 plus 1, which is 3. This is the case. And in the next portion it is starting with 1, 3 plus 1, which is 4, 3 plus 3, which is 6, 3 plus 1, which is 4, and this is 1. Now this triangle is known as Pascal triangle. And let me show you how. See, in this Pascal triangle, if I just mention the rows 0, 1, 2, 3, 4. See, first row is 0. From 0 items, I can pick only 0 items. So 0C0. What is 0C0? 0 factorial, 0 factorial, 0 factorial. That is 1. So this 1 is present here. What is the first row? First row is this, and first row with the first row, and this first portion is 0, second portion is 1. How many times I can choose 0 items from 1 items? How many times I can pick 1 item from 1 item? So this is 1C0 and 1C1. What is the value of 1C0? That is 1. 1C1 is also 1. Third row is 2C0, 2C1, 2C2. What is 2C0? That is 1. 2C1 is 2 factorial divided by 1 factorial divided by 1 factorial. That is 2. And 2C2 is 1. What is the third row? Third row is 3C0, 3C1, 3C2, 3C3. 3C0 is 1, 3C1 is 3, 3C3 is also 1, 3C2 is 3. So see, are you getting the idea that this row number is n and the column number is r, NCR. So this is the NCR, and this NCR I can fill. If I just fill this table, this will be something like a DP table for my NCR formula, and this NCR formula I can figure out at every step. So this Pascal triangle I'm going to use to capture the NCR formula that I'm going to use, and in every recursion tree I'm going to calculate the number of k. So for every k, to capture the answer, I have the formula n-1 c k-1. Now I will show you the code. Let's have a look on the optimized code using DP plus Combinatorics. Here first of all I have calculated the value of nck efficiently. To calculate that I have used Pascal triangle, and this Pascal triangle is going to do it in the n square time, and you can have a look on the code. To store this Pascal triangle, I have taken a 2D grid of size n+1 because I want the index as max as n and as max as 14. So it is of size n+1 and 15. So this Pascal triangle I have filled completely in the n square time, and this is something I have taken globally so that I can access in the DFS function. After that I'm using the memorization table. See, the memorization table is also reduced now because the length is till 15. The length can go till 15 because we are only considering the unique values, max plus 1 plus 15. So here this is the variable I am taking, and see, I am going to start from every single position, but starting from every single position, let's say starting from 1, I can have four possibilities. Let's say 1, 2 and 4 and then 8 and then 1, 5, 10, 15 like this. And if at any moment the value is less than the maximum value, the starting value less than the maximum value, I'm just not going to consider that. So for every possible value, every possible length, I'm going to start from every possible start value and calculate the ways of doing it. See, let's say that for value of k is equal to 3. The value in our example that we discussed, the value of n was 4 and the value of k was 3. It means 3C2 was the answer. But this 3 3 is something, 3 size change of unique elements. Let's say 1, 2 and 4. This is also one option, and this 1, 4, 8, this is also one option. Not in this case where the value is less than 5, but still, let's say 1, 3 and 6, these can also be there. So 3 size options can be so many in number. So all the ways we have to figure out the ways into n c n minus 1 c r k minus 1. So this is my formula that we derive in the discussion. N minus 1 c r k minus 1. This value is already stored in the form of Pascal triangle. So order of 1 time we can get, because we have already spent n square time in preprocessing. And the number of ways is something we need to figure out. And the number of ways is something every time I'm going to pick a unique value. The next value is double of the current value. In our previous recursion with memorization, the next value we were choosing the same value. So in that case, the depth of the recursion can go till 10 to the power 4. But here in this case, it will go till 14. So this is something about this hard problem where we utilize DP plus Combinatorics. And I hope you understood the approach. Here, recursion with memorization is more important, but we also need to know how the Combinatorics is going to help us save time. Here we have reduced the time because in this case we are not going till 10 to the power 4 depth. So this part, the time is optimized, but we have still introduced the Pascal triangle, which is going to take n square time. So overall it is n square time complexity. And just write the code and submit by yourself, and just try to understand it. If you still don't see or face any trouble understanding it, just discuss in the Discord community, and you will be able to find the link in the description below. Thank you guys. Thanks for watching. Bye bye.